A very good evening, respected Principal Sir, Professor Vijay Kumar Upadhyay, and respected coordinators, Dr. Kabiri Mojumdar, Associate Professor, and Dr. Kabir Chakraborty, Associate Professor and Head of Department, respected colleagues, participants, expert speakers. I cordially welcome you all to this ATAL online series faculty development program on energy sustainability and climate change on behalf of Electrical Engineering Department of Tripura Institute of Technology. I am pleased to inform you that we have among us Honorable Principal Professor Vijay Kumar Upadhyay. Thank you, sir, for from your busy schedule. And I am also delighted to inform you that very shortly the expert speakers are going to join us, so be with us. Now, coming to the scope of the FDP, I would like to mention that energy sustainability and climate change are nowadays global issues. So we cannot think of a modern society without energies. And sustainable energies include any energy source that cannot be depleted and can remain viable forever. Sustainable energies are very much environmental friendly and do not hamper the climate change. So our expert speakers and coordinators will give much more insightful thoughts on these topics. So I would like to start today's session, inaugural session, with a warm welcome speech by our coordinator, Madam Dr. Kabiri Mojumdar. Madam, please.
Hey, very good evening to everyone. It is our very great pleasure to welcome you all at the ATAL online 6 days faculty development program. on energy, sustainability, and climate change, which will be conducted within the period of 16th January to 22nd January. We are very much thankful that we have with us our Professor Abhijit Chakraborty sir, our Honorable Principal Bijay Kumar Upadhyay sir, our Honorable Dean Academic Madam, Professor Jhunu Debbarma. I would like to extend my sincere gratitude to our distinguished guests. Energy, sustainability, and climate change are interconnected with global challenges. Without energy, modern life is quite impossible. But meeting energy demands without compromising the resources for future generation is a major concern nowadays. Sustainable energy includes any energy source that cannot be depleted and can remain viable forever. Our FDP is designed to empower participants with an in-depth understanding of uses of renewable energy resources, effect of climate change, and concepts of sustainable energy resources. Overall, this FDP will provide a strong foundation for future research and practical applications. AICT Training and Learning, that is ATAL Academy Scheme, is an initiative by the AICT to provide faculty development program for technical institutions of India. We are very much thankful to AICT for giving us this opportunity to conduct the program. In our program, total 7 academicians and 6 industry experts will give their valuable lectures. Some of their areas of lectures are grid security, optimizing energy for sustainable future, EHV substation, floating solar PV, sustainability in power system, power saving mechanism, etc. I welcome each and every participant to join all the classes. There are total 13 classes and every day 2 classes will be conducted. A test shall be conducted online by the coordinator at the end of the program. And the certificates will be issued to those participants who are registered on ATAL portal and will maintain attendance of 80% in this program. It is our pleasure to have all of you in our FDP, and we are looking forward for a productive and enjoyable program ahead. Thank you all.
Thank you, madam, for your informative words. Now I would like to invite our Dean Academic Madam, Professor Jhunu Debbarma, to share her valuable thoughts on this topic.
I think Jhunu madam has some technical issues maybe there.
Okay.
Jhunu
She
madam?
might be taking.
Jhunu madam?
Okay. I think she might be facing some technical difficulties. May I now request our Honorable Principal Sir to share his valuable thoughts. Sir, please.
Thank you, madam. I think I am audible.
Yes, sir, you are audible.
Good evening, everyone. We are here meeting all virtually in the inaugural session of a 6-day ATAL online faculty development program with the title Energy, Sustainability and Climate Change. So in this program, we have the kind presence of one of the very eminent, towering academician in the engineering domain, Professor Abhijit Chakraborty. It is our proud privilege to welcome you, sir, in the inaugural session of this faculty development program, who has served as ex-professor, ex-HOD, Department of Electrical Engineering, IIEST Shibpur, former Vice Chancellor, Jadavpur University, Kolkata, former Vice Chairman, West Bengal State Council for Higher Education, and having an experience of uh, as high as 42 years. So it is really our proud privilege to have you on this inaugural session, as I have learned that, sir, you will be delivering the first lecture of this 6 days ATAL FDP on energy sustainability and climate change. On behalf of Tripura Institute of Technology and the entire electrical engineering department, it is our proud privilege to welcome all participants who are basically academician or research scholar or students. Uh, and this is our proud privilege to host this particular faculty development program for advancement and sharing of thoughts from the experts to all of us, which I am very sure that will be beneficial for all the participants. I would like to thanks AICTE for giving us this opportunity to organize this national level faculty development program in our institute, though it is in virtual form, but this form seems to be most convenient as it hampers, affects our normal activity very less, and participants can also uh, involve in all these sessions minutely, as it has been designed between 6 p.m. to 9 p.m. So which in some cases otherwise also challenging, because beyond the normal working hours, sometime it may be a little difficult, but I'm sure we are all committed, and the uh, the academicians, the experts that have been chosen and requested, who has given their kind consent to deliver the talks on the various issues, especially in the sector of the FDP, are very renowned academician. So we are very committed, we are very enthusiastic to attend all the sessions. And regarding Tripura Institute of Technology, it is a technical institute which was the first technical institute in the state of Tripura. It was a polytechnic institute started in the year 1958 with 3 branches of polytechnic diploma engineering curriculum in civil engineering, mechanical engineering, and electrical engineering. Then with the uh, in the year 1997, the fourth program was added, which was electronics and telecommunication engineering. And in 2001 onwards, there was a project, World Bank assisted project for modernization of laboratories and overall development of the Polytechnic Institute, that was TAKED 3 project. So with this project opportunity, the institute have been grown and many other diploma programs has been introduced. And looking at this, government of Tripura has upgraded this institute to a degree level engineering college in the year 2007. So from 2007, this institute is known as Tripura Institute of Technology, from leaving the Polytechnic Institute name there. And in the year thereafter, initially 4 branches were introduced in 2007 in BTech program, and in 2010, electrical engineering BTech program was also introduced, followed by in 2020, the PG programs have been started. 3 PG programs in 2020 started, followed by 2021, the 4th PG program has been started. The faculty members are very committed, very experienced. Faculty members are there in the institute who are, many of them has completed their PhD programs, and some of them are pursuing. And we are aiming this institute to take next phase also by introducing PhD program. Even talks are going on to convert this into a technological university in the state of Tripura. So we are very optimistic and hopeful with the kind blessings of all senior people in the engineering fraternity, and with the well wishes of all academicians across the state as well as the country. We hope that this institute will reach to its peak with name and fame. I once again congratulate our electrical engineering department, who is hosting this uh, faculty development program under the coordinatorship of Dr. Kaveri Majumdar, and under the guidance of Dr. Chakraborty, who is head of the Department of Electrical Engineering Department, and all the organizing team and the faculty members involved in organizing this faculty development program in a befitting manner. Thank you, everyone.
Thank you very much, sir. You have always been very much cooperative and supportive while organizing such kind of programs. Now, I am feeling very much delighted to announce that we have among us very much renowned Professor Dr. Abhijit Chakraborty, Professor IIEST Shibpur, former Vice Chancellor Jadavpur University. Sir has also served the Sir has also served as the chairman of West Bengal State Council for Higher Education. So we all are eagerly waiting to hear the valuable thoughts from Sir. So may I now request Sir to share his thoughts? Sir, please.
Thank you. I hope I am audible.
Yes, sir, you are audible.
A very good evening. It's a nice winter evening, and it's a fine time to have an interaction with you all. At the very first, I convey my sincere gratitude and welcome to Dr. Upadhyay and the senior faculty and all the faculty members of Tripura Institute of Technology. It's a nice time that you have started this program, and periodical program of such type, obviously it improves the faculty quality and it motivates the young faculty to reach to greater heights. Now, regarding the topic of the program, It's very interesting and it's very timely. Its energy sustainability is a very, very big issue nowadays. In each and every country, this is a very important issue, and the engineers, scientists, and the persons related with this field are very much concerned about this issue, because the fossil fuel and the conventional energy, uh, like nuclear energy and others, they are not very much uh, friendly, particularly the climate friendly. So nowadays, slowly, we are trying to discontinue with such type of energy generation. Rather, we are trying to improve the non-conventional and renewable energy sources. But that is the challenge, and each and every country is facing that challenge. It's not very easy to harness the non-conventional and renewable energy suddenly or in a very short time. Moreover, once the energy is generated, it is to be transmitted and distributed properly. So transmission system is getting more complex day by day. And because of many reasons, we need to give maximum attention towards sustainability of the transmission system, so that the energy generated in different form is properly utilized by the people for whom it is generated. In our country, because of diverse demographic character, in many areas there is huge demand for energy. In some areas there is less demand for energy. So energy planning is very tough job, and the engineers are trying to make this system in such a way so that each and every person gets the electrical energy. And electrical energy is a key factor for developing for the society. So it is very important that proper attention is to be given. So energy sustainability is a very big issue, and it is the time to discuss this issue in this forum. And the people will be hearing different expert lectures, and they will gather knowledge, and they will be motivated to go for further research and application on this topic. The climate change is also another very important issue, and you see that because of the climatic problems, climate change, many problems are appearing, and we are facing, starting from health to energy to other sectors. We are facing typical problems which we have not faced in 20 years, 25, 30 years back. So climate change issue is to be addressed properly, and it is one of the biggest challenges nowadays to maintain the proper climate so that Earth is habitual and is habitable for us. So this topic is also important, and amalgamation of these two topics can give a good output. It can give a good outcome, so that the young persons and the participants, they get motivated by the expert talks on these issues. So I think that this is a very timely topic you have selected, and I wish that this entire program becomes a success. Thank you.
Thank you very much, sir. Your words were really very motivational and thought-provoking in true sense of the term. Also, we are very much thankful to you, sir, for giving us time from your busy schedule. Now it's time to hear from another renowned speaker, Engineer Debabrata Pal, Senior Manager, Commercial, Power Market Trading, TACCL, Tripura. Sir, please.
আজ জয়েন করছিল
I think Sir is not able to join us due to some issues. So I would like to request our coordinator, Dr. Kabir Chakraborty, to convey vote of thanks in today's inaugural session. Sir, please.
Thank you. Respected distinguished dignitaries, esteemed faculty members, and my dear colleagues. On behalf of the organizing committee, I feel honored to extend my heartfelt gratitude to everyone present here today for joining us at the inaugural session of this faculty development program. First of all, I would like to express my sincere thanks to Professor Abhijit Chakraborty sir for gracing this session with his esteemed presence and valuable insight, which has set the tone for the session ahead. A special thanks to our Honorable Principal for his unwavering support. Without your vision, initiative like this would not be a reality. I would also like to acknowledge all the resource persons who will conduct the sessions during the next 6 days of the program. Your expertise will certainly empower our faculty members. Finally, my heartfelt thanks to all participants for showing their interest towards enriching your skill. Let, let us look forward to a fruitful and enriching FDP. Thank you. Thank you all.
Thank you very much, sir. With this, I would like to conclude today's inaugural session and hand over the session to our coordinator, Madam Dr. Kabiri Majumdar.
Hello. May I audible?
Yes, you are audible.
Okay, sir. Sir, may you start the program now? May you start your class now, lecture class?
Okay, let me start.
Oh, okay. Thank
Okay.
you, sir.
Let me first share the screen. Is it visible?
Yes, sir, it is visible.
Okay.
Sir, you may give full hand.
Today, I would like to discuss about the power grid security. Now, power grid security is a conventional aspect of power system, particularly in the transmission sector. Now, recently, within, say, last decade or slightly more than that, there are some critical issues that we have faced across the globe, and that has to some extent changed the concept and definition of grid security. Now, conventionally, during, say, around 25, 30 to 5 years back, when we talked about the security, we used to refer the grid, the power system, how much it is stable during contingencies. In most of the cases, those were static analysis, static issues, and in many cases, those were dynamic issues. And they were all related to mostly the outages, trippings, generation drop, load throw, and related problems which were very common in the power system. Now, because of the requirement of electricity and because of increase of per capita consumption of electricity across the world, and because of more use of electricity by people, the consumer awareness factor has gone high. And day by day, our expectation for a reliable, stable, secured, and better supply, that expectation has increased many folds. We are very much interested and we want that the electrical power supply is uninterrupted, and this uninterrupted power supply is possible if the three major components of the power system, that is generation, transmission, and distribution network, they are properly secured against any outages and attacks. Now, these term attacks should be properly taken care of. What I was telling a few minutes back, that we were mostly concerned about the conventional outages, including planned and unplanned one, including maintenance jobs also. But nowadays, because of many instances across the globe within last 12 to 15 years, we are now concerned against attacks. These attacks means there are either physical or cyber attack on the power system, particularly the grid and adjoining power system transmission sector, so that the system gets crippled. And this may lead to severe repercussion, severe power failure, complete blackout, islanding, etc., etc. And this has become a big issue because the grid network has become more complex because of increased number of buses, lines. So unplanned outage and attack in a particular section of the grid may lead to vulnerable collapse of the entire grid system. We know that power grid is basically the heart of the power system. So it is very important that it is secured. So security of the network is a very important aspect when we talk about the grid network and security of the grid. So we must tackle the unpredicted outages and attacks on grid in a proper way so that our grid remains secure. Now, how to predict such failures, such events, or how to analyze such calamities, such vulnerable collapses? If you go for a literature survey, you will find that within last 20 years, the researchers, they have mostly they have developed or they preferred the topological model of the network to analyze the vulnerability and resiliency of the power network. We discuss both. Now, it is important that while we go for analyzing the complex power grid, we need to model it properly. And it has been observed by many researchers that the complex network theory is a very good method of analysis which can give a excellent model for such type of analysis. And this can be done during normal operation as well as during contingency. And since last 45 years, numerous work have been done in simulating the power grid and analyzing it during different operating states, including the period of electrical failures. But within last 20 years, we are much concerned about the unplanned attacks and unplanned outages and attacks. This entire world is now facing the threat at different sectors of life, starting from communication system to economical backbone of the society, and even the electrical power grid. Electrical power grid could be a soft target for the terrorist for such an attack. And it is very important that the power grid needs proper analysis during unplanned outages and intentional attacks, and we need to identify the sensitive areas in this network. And I have just told that complex network theory is a very important tool to model the power grid network for the study of its behavior during pre-attack period or pre-disturbance period, during disturbance period, and after disturbance period when the disturbance is over. So this complex network theory is a very good concept, and it helps to find the vulnerable lines of the system so that preventive measures can be taken for their protection during critical states. Now, we will invite a few new terms which are very much related to complex network theory, applicable to power system analysis. First, we will talk about the efficiency. It's not the conventional efficiency that we know, that is output by input. No, it is not that. In complex network theory, when it is applied to the electrical power system, we call the efficiency a parameter that is introduced to evaluate the tolerance of the complex network to outages. It's a tolerance. It's a degree of tolerance. How much the network can tolerate a outage, that is the efficiency. How much the network can tolerate an outage, it is the efficiency. On the other hand, the performance of the network following a contingency is assessed by the term netability. So efficiency is the capability of the tolerance, and netability is its performance post-contingency period. Now, these are all metrics. Netability is a very important metric, and it describes the resiliency, while the basic building block to assess network netability is the vulnerability of the network. So once we go for netability, so netability is a qualitative term, but we want to quantify the concept. So we use the term vulnerability of the network, which can be quantified, and this quantification of vulnerability gives us netability. And resilience is also included in this concept. We will come at the, after some time about the concept of resiliency and discuss about the same. These terms are incorporated from the topological approach, but while we include it in the power system, we need to include different physical properties and constraints like line flow limit, power transmission capability, and PTDF, power transfer distribution factor. PTDF plays a very important role in contingency analysis. This you all know. Now, PTDF is used here so that we can model the system during contingency in a very effective way. Now, let me recall the concept of PTDF. What is PTDF? It is basically an incremental change in the active power, that is the real power, which occurs in transmission line due to real power change or real power injection change between two regions. Let me simplify it. Suppose we have two lines. We are talking about two lines in a transmission network. Say two lines, line A and line B. Line A is between, say, bus S and T, and line B is between bus P and Q. Now, what is the incremental change in real power in line A because of incremental changes or because of real power changes in line B, or because of injection in the buses connecting line B? So, in case one line or one bus or more than one bus gets affected because of the power changes, tripping, load throw, power injection, reactive power failure, fax device incorporation, etc. So whatever be the factor, whatever be the change in that B line, how it will affect line A. So that qualitative definition is quantified using the factor PTDF. Now, while we talk about the grid, we always take the grid as an infinite grid. The main grid is an infinite grid. It has got zero internal impedance and infinite rotational inertia. Now, zero internal impedance gives us that whatever be the load on the grid, whatever be the current in the transmission lines, the grid voltage remains same. That is, incremental change in grid voltage, deviation in grid voltage is zero. The grid voltage always remains same, infinite grid. And also, the frequency does not change. That is infinite rotational inertia. The generation system has infinite rotational inertia, so the frequency does not change. So this we always take into account. Now, in our country, while we go for such type of analysis, we first need to see the regions we have. We have mostly 5 regions: northern region, southern region, eastern region, western region, and northeastern region. Now, the well-functional grid is essential for exchange of power between these regions. So this is very important. Now, the grid is very much susceptible to disturbance. As it has become very complex, so it is very much susceptible to disturbance. And in case the disturbance are not prevented or arrested in time or mitigated, it may lead to a collapse of the power network. Now, very broadly, we can classify the disturbances depending on the few factors that I have listed below. These factors you can see, first is dynamic operating condition. Say a major load fluctuation, say a degeneration drop, say change in configuration of line, tripping of line. So these are dynamic operating conditions. Then network interconnections may change frequently. That leads to system topological change. Then there may be uncertainties due to rapid growth in the demand of electricity. Then some power system components in some heavily loaded areas may run closer to their designated limits. So that time, because of their operation close to their design limits, it may happen that slight overloading leads to failure of the component or overheating of the component. So that can make a relay trip protection system operation, and there may be some grid disturbance. And the next point is very important. Nowadays, we are very much interested to inject energy from renewable sources. So this penetration of renewable sources adds to issues like power quality and control. So this is a very broad view about few factors which can disturb the grid from the electrical point of view. Is a very common this grid structure along with the network components, starting from energy generation, energy storage, renewable energy storage, then the power plant, transmission lines, then your distribution system, customers, etc. It's a very broad pictorial view. So in a grid, there are a number of substations, generating stations, all are interconnected. I can remember a power blackout during 2012 in July 30-31 that has led to severe repercussion and severe financial loss in our Indian power system. On July 30, 2012, at 2:35 a.m., the grid collapsed, though the line frequency was above normal, near normal. The problem was possibly local in the northern grid. As far as we know, there was a grid transformer tripping near Agra that led to this disturbance. The transient stability was lost associated with the problem of voltage instability. It was restored in the early morning, but as soon as the restored, the sugar mills, the sugar mill owners are very influential in the UP. So sugar mills were started abruptly, immediately, and that led to huge demand of power in the northern region close to Kanpur. And again, there was a failure because of overdrawn of power from the weak grid. That time it was a very weak grid once it is restored. And that was restored at the late evening, and then because the grids were interconnected, northern and eastern and northeastern, so there was major collapse. And you might have seen that the areas that suffered major collapse were indicated here. Now, the southern grid was not affected, and the western grid was also not much affected. The reason it was there, the southern grid is mostly connected with the northern grid and eastern grid through HVDC lines. So that saved the southern grid and western grid, and the HVDC lines are less in number between interconnection of northern and eastern and northeastern grid. So these grids suffered the most. And you know that impacts of the blackout: daily life badly hit, trains transportation stopped, school, colleges, public offices were shut down, huge economic losses, bad impression of the affected country, and many more. Now let us come to our core of the discussion. While we discuss, we need to review some concept of classical complex network theory which is applicable to our system. First, we see the concept of geodesic path. say there are two buses, I and J. So geodesic path is the shortest path. That is the path with minimum length between these two buses, and the geodetic distance is denoted by dij, and in case the graph is weighted, then this path is having a minimum sum of edge weights. So the edges are practically the lines and the nodes are practically buses. So a geodesic path may contain many lines, but it should be a minimum path. And how do we represent in our system? You just recall the Z-bus matrix. So in Z-bus matrix, Z-bus ij is the geodesic path when it is having the shortest electrical distance, that is the geodesic distance. Suppose in a Z-bus matrix, there are many entries. So out of these entries, if you study the off-diagonal entries, the off-diagonal entry which is a minimum value, that is the best geodesic path. We can represent this geodesic distance between node ij through path k by this PTDF. This PTDF subscript k superscript L means that it is the PTDF of line P in path k, while ZL is the impedance of line L. Now, this PTDF, what I was telling, PTDF between bus ij, because of power exchange between line XY, is denoted by the ratio of the incremental power flow through branch ij due to transaction in XY and power transaction from XY, which is shown here. And we can represent it by the B matrix also. I am not going into mathematical detail. I am just giving you the. Now, we can denote L as average shortest path length by this where N is the number of buses and Dij is the geodesic distance. We can denote connectivity also by this formula shown here, where Lij represent the number of lines connecting buses I and J in the number of nodes, and Dij is the geodesic distance between the buses I and J. Now let us come to global efficiency. Efficiency, I have told you few minutes back. So efficiency is mathematically denoted by 1 by n into n minus 1 summation 1 by Dij. Now from here, now we can see the vulnerability. What is vulnerability now? Now we check the efficiency when all the lines and buses are intact. That time we calculate efficiency. Now suppose one bus or one line is stripped. So that time we recalculate vulnerability, which is E suffix L. So this change E minus E suffix L with respect to E gives the vulnerability, while E minus EL is the drop in efficiency for loss of line L. So this is the quantification of the vulnerability. This is the formula that I have shown here, is the netability. That is the measure of drop of network functioning due to tripping or removal of one line or node of the power grid network. Now here you see that Pij superscript k is the power share of path k in transmitting power for Ij, and Dij is equivalent to Z bus matrix component Zij, and I have shown all the nomenclatures here, and we can calculate the vulnerability from the concept of netability also, using that when the entire grid network is intact, what is the vulnerability? That is A. And when the line or lines are tripped, what is the vulnerability? That is AL. A minus AL is the drop of vulnerability. So it should be A minus AL by A. It is not E. It is a printing mistake. A minus AL by A. Now betweenness, now I can introduce another concept, that is betweenness. Betweenness is a tool that quantifies the influence of a node or edge of the network in assessing the state of operation of the network. Suppose in a complex network, in the grid network, a particular bus is very much loaded. A particular bus is supplying huge load, or it has many interconnections. So that particular bus has a great influence to the system. In case there is a failure of the bus, or similarly, if there is a failure of a heavily loaded connecting line, so that time it will have a tremendous effect on the security of the grid. So that concept is the betweenness. So if the element has very high betweenness, that indicates that it has got high influence on the power flow of the network. And betweenness of the element in the network is measured by the counting the number of geodesic through it. So betweenness of a node is given by the formula shown here, where P is the number of all possible shortest path between S and T bus, and PSTI is the number of those paths for node ST through node I. So fraction of all shortest path between any pair of ST nodes that touches I. So electrical node betweenness is given by this expression. Here CGD, this is basically a power, that is half CGD FLGD is the transmission power taken by bus V, and when the power is transmitted from generator bus to load bus D. So this is the formula to calculate the betweenness of a node. Similarly, we can calculate the betweenness of a line. So that is given by this expression. So we need to calculate the electrical line betweenness of the line as well as the electrical line betweenness of the bus. And then we can rank the buses. So vulnerability of a network is a very useful concept, and it assesses the possibility of failure of the network. The vulnerability becomes high, and it becomes more prone to failure for the network. And mathematically, the vulnerability can be assessed by measuring the netability of the network under consideration using the formula we have shown earlier. Betweenness metric can be used as another tool for assessing vulnerability of the complex power network. Now, these are the possible causes of vulnerabilities. You see, this unfavorable weather events is very important nowadays. Then grid transformer failures, or main big transformer failures, substation transformer failures, cyber attacks, line faults, generation resource disturbances, and targeted attacks. The targeted attacks in most cases are assumed to be physical attack, whereas cyber attacks are through internet. A cyber attack through internet can inject bug in the control system of a component, and it can malfunction. Say a relay, say a circuit breaker, like that. And targeted attack can be a physical attack on the line that will trip the line and has a very bad effect, a very negative effect on the entire system. Now, how to identify the vulnerable lines? What are the steps? When you go for analysis, how do you do it? The power system is modeled according to the concept of complex network theory. Then proper weights to the connecting transmission lines are added based on governing values of the line reactance. When the line reactance is more, we give more weight to the connecting transmission lines. Then it is required to find the electrical betweenness of the line using the nettability approach. That is A minus AL by A. A is the nettability when the entire system is intact, and AL is the nettability when, say, a transmission line or a pair of transmission lines is out of order. Then the lines with high betweenness are to be taken for nettability calculation, which I have just shown. Usually, we take first 5 high betweenness lines, and they are chosen to compute their corresponding nettability values. The vulnerability of the above 5 high betweenness lines are assessed using nettability metric, with each of the lines being removed on priority basis from high betweenness to low betweenness. It should be clear now that betweenness, high betweenness does not mean it is heavily loaded. High betweenness is the problem that is dealing with the nettability. So a very low capacity line could have high betweenness. And the removal of lines may be because of single or double contingency. Now we show a simulation. In a standard IEEE 57 bus, we simulate. The 57 bus test system is plotted here, and its topological model is also shown. Now, once the simulation is done, we calculate the betweenness. If you look at the left-hand side graph, you see that we calculated the node betweenness. And you see here that the highest node betweenness is for bus number 12. The bus number 12 is having the highest betweenness. This is the highest betweenness, bus number 12. So if bus number 12 is stripped, the entire system may be geoparatized. It is not important that bus number 12 is heavily loaded, but it has got high betweenness. So if there is a targeted attack on bus number 12, or there is an unplanned outage related to bus number 12, the entire system may be in problem. If we talk about the line betweenness, the right-hand side graph, we see that line number 79 is having highest betweenness. So line number 79 is very much prone for any unplanned outage or attack. And this is very important study that I cannot say that line number 79 is the heavily loaded line. It could not be heavy, it may be heavily loaded, it may not be heavily loaded. But betweenness is very high. That is, it has got maximum influence on the system. Now it is another simulation for single line and double line outages. Now, if we trip line number 79, we see that vulnerability becomes 14.37%. The vulnerability is high, 14.37. In electrical grid calculation, this 14.37 is a good figure regarding vulnerability. Line number 25 is next one. This is also close to 14. And then the other lines. So 5 lines betweenness are calculated, and we have seen that tripping of this line or this line has got remarkable effect on the system. If we take double line outage, 79 and 25, first and second highest betweenness line, then the vulnerability goes to as much as high as 34%. So 34% vulnerability is a very big figure, and that time it may be difficult to retain the system. And we have run the simulation to see that with 34% vulnerability, the system becomes prone to islanding. So there are different results we have got for tripping of different lines. Say with 79, say line number 27 is tripped, then the vulnerability is much more less than this one. That is only 15.77. Though it is not very less, but with respect to the earlier one, it is lesser. Similarly, for the other cases, we have done arbitrarily with 79, all the other high betweenness lines, if they got tripped, what is the effect? So that is shown here. Now, if there are 3 line trippings, so in case of 3 line trippings, you see if 79, 14, and 25, these 3 lines are tripped, the vulnerability is exceeding 33%. It is close to 34%. So this is very high. Now, similarly, we can do for others also. As just an academic exercise, we have tried to incorporate DGs, the distributed generation, to see that how incorporation of DG affects the vulnerability of the system. We have seen that DG operation, if it can be timely operated, then it reduces the system losses and enhances the voltage profile during steady state operation. During any contingency, if the DGs can be immediately brought into service, then there is a possibility that we can reduce the vulnerability. That is, if we can incorporate the DG in proper time, the quantification of vulnerability results in a much lower value. A 14-bus system, more simplified it is, we see that the line number, node number, that is the bus number 5, is having highest betweenness. So bus number 5 is very prone to influence the system in case there is a failure in bus number 5. You can identify here bus number 5 and see that bus number 5 is very much important, and it is having much influence on the system. Now, in this IEEE 14-bus system, if we see the vulnerabilities for outage of lines, we see that for these line numbers, line number 14, which we have just seen in the earlier slide, is very high betweenness of around 29. Vulnerability, 29% is very high. So line number 14, which you can see from here also, line number 14 is a very critical line. And if we can predict or we can assess that this line number 14 is very important, we can pay our maximum attention towards retention of this line. So this is a very important exercise. Now we have seen that some components, line or buses, had got very high influence on the grid system. Now, in many cases, such failure of such components lead to cascading failure. This leads to cascading failure. Cascading failure in the power grids are successive interdependent failures of the components in the system, which are originated by a few outages due to internal or external disturbances and are propagated in the relatively short period of time leading to blackouts. The probable causes. Probable causes leads to sudden load burdening, severe overload, resource exhaustion, say generation drop, defective load management, inaccurate capability or inaccurate capacity planning, and delay in communication response. These are the broadly classified probable causes of cascading failure. Now, if we see mathematically the cascading failure, we can tell that each line can be associated with a definite value of electrical betweenness. Each line is having an electrical betweenness that we have seen. Now, we incorporate a tolerance factor and we express it by TGD max. Now, T bracket L is electrical betweenness of line L, and delta TGD is the change of electrical betweenness. Following collapse of a overloaded line, the additional electrical betweenness is transferred to an adjacent line, and it is given by this expression. Once a line gets stripped, its load are distributed in other associated or adjacent lines. So the electrical betweenness is getting transferred to the adjacent lines. Now, the outage of a line or a bus alters the shortest path, and power flow of the tripped line gets redistributed following the concept of preferential probability. Now, load strength of the node. Now, this is the preferential probability. This is the expression for preferential probability. Now, once we know this, we can go for the method to know the flowchart of cascading failure. This is the flowchart for cascading failure determination. Now we have done a simulation for 57 bus system. I have told you earlier that line number 79 is of highest betweenness line. So when line number 79 is stripped, the betweenness is distributed in adjacent lines. You see 10, 11, 13, 15, 25. And you see that this is the maximum power capability. This is the maximum power capability that could be achieved, and this is the power that is available. Now you see here that the maximum power that is possible for line number 11, you see 11 is 20 megawatt, whatever you tell, say 20 megawatt. So 20 megawatt is surpassed here. In other cases, all these values are less than the maximum power. So in this case, this line will obviously trip. So line 11 is stripped. When line 11 is stripped, the betweenness gets distributed among these lines. And among these lines, if you see for line number 12, again, this power is higher than its capacity. So it will trip. Once it is stripped, this line number 11, it is stripped. It will be line number 11 and line number 12. Once line number 12 is stripped, so betweenness is getting distributed in among these 4 lines. So you see again that line number 21 is overloaded, heavily overloaded. So it is stripped and it is distributed between 2 lines. And it is again stripped. So it is single line. So islanding takes place and this leads to cascading failure. So if you go for tripping of line number 79, then you see that it leads to cascading failure through this mechanism. So this is a very interesting exercise to see how the high betweenness line is influencing the operation of the entire system and leads to cascading failure. It can be done for any system. Now we come to resiliency. Now resiliency, basically it is coming from a Latin word resilio, which means that how is the ability, what is the ability, how much is the ability of an object to rebound or return to its original shape or position after being stressed the power or ability to return to the original form and ability to recover readily from illness, depression, adversity. This is a common definition. So this we have utilized in our power system. That is, in power system, suppose the system is operating normally. Suddenly there is a disturbance. Now disturbance will prevail for some time, few seconds or few minutes like that. And the system will try to adapt the disturbance. With operation of the protection systems or operation of the mitigating measures, the system is trying to regain from its disturbance. The disturbance is over. Now, once the disturbance is over, the system will try to regain its original state. This try ability, that is, this capability is the resiliency of the system. How much it is capable to rebound to its original shape or state, that is resiliency. So resiliency is withstand any sudden increment, weather or human attack on the infrastructure. It is to respond quickly, to restore balance as quickly as possible after the disturbance. It is to adapt the new operating condition while maintaining smooth functionality both locally and globally. And whether the system is predict or to prevent such attacks in future based on patterns or past experience, that is the 4 attributes of the resiliency. Now, proper incorporation of DG, we have seen that it improves the resiliency. It not only improves the betweenness, mutability, but it also improves the resiliency of the system. It improves the static voltage profile. It improves the losses, that is, it reduces the losses, and the DG reduces the betweenness and hence the criticality of the most critical buses. Now, what are the common disruption affecting power networks? Here we have classified. The very important is atmospheric disruption, which we are now facing because of the climate change. We face floods, severe storms, snowstorms, tropical cyclone and landfall, tornadoes, and droughts. These affect critically the system. Then we face geophysical or geological disturbances like wildfire, which is happening in Los Angeles. We see volcanic eruptions and earthquake. Terrestrial disturbances, geomagnetic storms. Biological disturbances, pandemic like corona. So, in addition to these, nowadays, we are very much susceptible and we are concerned about man-made disruptive events. The man-made disruptive events include explosive attacks, armed attacks, and technological failure, as well as sabotages, use of mass destruction like airstrike, nuclear attack, bacteriological attack, biological attack, chemical attack. Economic crisis, climate change due to our man-made climate change, and cyber attacks. So these events of disruption affect the power network badly. And this leads to the failure of the network. So resiliency is very important parameter which can deal with such type of events, disruptive events. The attack scenario includes attack or outage of bus and attack or outage of line. These are most two important. The bus includes the equipments connected with the bus, and the lines include the equipments connected with the line. So such type of attacks are very much vulnerable for the network. Now, frequently, we confuse between reliability and resiliency. Now, in a very broad sense and a very simple sense, reliability is the capability of the system to provide uninterrupted service, overcoming the commonly occurring disturbances. Commonly occurring disturbances, how we can tackle and provide uninterrupted service. So these qualities, reliability. And resiliency is a system's preparedness, system's capability to handle the disruptive event and restore the system as close as possible to the pre-disturbance state at earliest time. So resiliency and reliability are entirely different two concepts. In case of reliability, it is low impact effect. And in case of resiliency, it is low frequency, high impact event. Low frequency, high impact, LFHI event. Low frequency, that is, it occurs, usually does not occur. Its occurrence frequency is low, but when it occurs, the impact is very high. And that is the disturbing event. And in case of reliability, it is high frequency HF, low impact LI, HF LI event. Frequently it affects. Frequently there is power disruption because of neutral disconnection, because of short circuit in one phase, because of transformer fault, like that. But impact is regional, impact is local. So in case of reliability, it is high frequency, low impact event. And in case of resiliency, it is low frequency, high impact event. This I have explained here, low frequency, high impact event. Till now, it has been very difficult directly to quantify resilience, as each type of LFHI event has different levels of unpredictability and impacts. The quantification of preparedness is just too difficult. Say, you quantify for storm. Now, suppose there is a flood. So the entire effect, impact is totally different. Say, there is an earthquake. Say, there is a pandemic. So impacts are entirely different in quality. The outcome is same, failure of the electrical system, but the impact is different. So it is very difficult to quantify resilience for each type of disturbance. And there are several publications at various levels of the system to develop resiliency metrics for various applications. The resiliency metric usually involves a process that consists a number of steps, like we have to define the objective of resilience, that is whether resilience for earthquake, whether resilience for weather event, whether resilience for cyber attack, or like that. What is our object? the system analysis with all possible and physical constraints. Characterization of threats. It's a very difficult task, characterization of threat. There are many threats which we cannot characterize directly through a simple model. Then assessment of disruption and impact. Sometimes we need to depend on the statistical analysis to assess the effect of disruption and impact. We do not know in case there is a earthquake in the Richter scale of 7, what will be the impact, and whether in case it is 6.8, what will be impact may not be same. So it is very difficult, and we need to depend on the statistical data. Simulation of the system using correct models. It is again a difficult job. Calculation of consequences and evaluation of resilient mitigating measures. The mitigating measures are different. In case of a man-made disturbance or disruptive event, the mitigating measure may be one, and in case of weather effect, it may be another. Outcome is same. We want to restore the electrical system to the pre-disturbance level, but the path may be different, but the process may be different. So it is very difficult to evaluate. As far as my knowledge goes, when we have scanned nearly hundreds of publications within last 20 years, I have seen that there are nearly more than 50 resilient metrics that is available in the literature. But most of the metrics are of academic interest. I do not know whether they can be really of use during practical problem. Whether this resilience metric is able to quantify the resiliency or it can assess the resiliency, that is not very sure. They are all effective in the academic level, in the lab level. But still now, we need to go for further research, how we can develop metrics for each and individual event of disturbance. So that is very important. Mostly, still now, we electrical engineers are very much concerned with development of resilience metrics from electrical point of view. But from biological and other point of view, the resilient metric development, I do not know whether they are up to the mark or not. So that is to be investigated. And I will say that the young engineers, young faculty, the young participants, I motivate you to go for further research on this development of resilience metrics, checking the impacts. Now, when we go for topological resilience indicators, which are very much connected with the topological theory, we introduce this formula, which indicates the size of the graph, the size of complexity that is indicated here. Then degree distribution. It indicates the number of lines arising out of a particular node. How many lines are coming out of the particular node? The degree of a node is the number of nodes connected to it, and the connectors of the graph are indicated by degree distribution. It is the probability distribution of the degree over the entire network. If the degree distribution is of high value, it indicates that there are nodes with high connectivity to the other network nodes. Then we see the percolation threshold. In order to observe these parameters, there is a need to apply the percolation theory. It's basically a statistical concept. Study reveals that there exists a critical fragmentation of nodes. This is very important. Please note that. a critical fragmentation of nodes, if they are removed from the system, it can have tremendous effect to island the system, to completely destabilize the system. This critical fraction of the system is known as percolation threshold. Say, a grid network is consisting of 10 sub-networks. If we see the percolation threshold of each sub-network, we can see the value of the percolation threshold of, say, sub-network number 6 is very high. Then I will tell that it is the critical fraction. If that fraction is affected, if the subgrid number 6 is affected, then the entire grid may be affected. So that is shown here. Now, the resiliency curves. A plot of system performance, which is usually denoted by QT in the literature, and the time is T. It is the graphical pattern of Q versus T to understand how well is system performance under HILF event, high impact low frequency event. Now you see that in case the cumulative damage probability is 0.5, that is the 50%, then for the times of 10 hours, if the disturbance is for 10 hours, then the damage probability is 50%. So this graph is basically derived from a statistical data analysis, and you see that there is a linear zone and there is a saturation zone. So while we calculate the resiliency, we need to know that what is the time of duration of the disturbing event, so that at what point we are, what is the probability of damage. So that is available from the resiliency curve. Then the fragility curve. It is not basically a resiliency curve, but it is a limiting point of resiliency study. Now, it is the degree of loss and intensity of hazard. If the hazard intensity increases, the degree loss increases in this pattern. It is a very important curve which can be quantified. This is a first attempt of quantification of resiliency. It is one of the earliest ideas of visualization of the resilience. Now, you see that the functional ability of the system is plotted here. Q100 means 10% functional. So the system before the disturbance was 10% functional. So here the system is 10% functional, no disturbance. This is the point of disturbance. At the point of event of disturbance, you see that the functionality drops to, say, 50%. And immediately measures are taken and the system starts recovery. As soon as the starts recovery, usually it takes a long exponential path which can be linearized like this. Many authors have linearized like this. And then after recovery, this is the post-hazard period. Theoretically, this should be again Q100, but sometimes it is less than Q100 also. Now, this is a triangle. So this is a triangle. So using the mathematics, we can quantify the loss of functionality from here. The triangular resilience curve sometimes does not provide the scope of understanding the withstanding aspect of the system, nor the latency in human resource deployment during the post-hazard period. Earlier, we have taken that As soon as there is a loss of functionality, that is functionality, immediately actions were taken and recovery started. But in practical cases, it is not there. So once the disturbance event appears, it takes some time, the system, to adapt it. And then it persists for some time. Recovery starts from here. That is, it is the preparedness for recovery, and then recovery starts. This is the recovery period, system restoration. And then we go to post-restoration state. Here the restoration process started. So here I have denoted these times by TD, T and TR. TD is the disturbance progress time. TD is the disturbance progress time. This is the disturbance progress time. Disturbance is progressing. And this is the post-disturbance degraded period. This is T. This time the functionality is very low. And then restoration started, because we were preparing for restoration. Restoration started, and restoration process continues till we go for post-restoration state. This is a very common practical resiliency curve. Now, this is a further subdivision of the resiliency curve into a number of time phases. Here you see it starts from time to anticipate and prepare. Here we anticipate that there could be an event, say a storm. We see that air speed is increasing, clouds are gathering. So this is a period for our preparedness. This is to assess the anticipate, and then the storm appears, the tornado appears. This is the initiation of the disrupting event. And the disruption continues for the entire period of T2. And during T3, when the system is degraded, that time, it is the time to respond and to adapt. That is, we need to maintain emergency supplies. We need to invite distribution generation. We need to invite other mitigating measures. So this is the time for that, when the system is trying to adapt the disturbance. Then restoration starts. Now we have a targeted restoration process, which is the ideal one, that is T4. But actual restoration process may take some more time, that is T5. So we need to assess all these time zones properly, so that we are fully prepared to challenge, to encounter the event. Now let us see some resiliency metrics. This is the best resiliency metric. This is the time duration when a consumer receives electrical power within the total measured time divided by the downtime. This is the downtime and total time. This is a resiliency metric, best resiliency metric. Then augmented. Here the total number of customers, grid, etc. taken into account. Then critical loads are there. And then this is another metric that we have shown here. Augmented resiliency metric. Then power resiliency metric. Now P out is the accessible paths from node S to T after an outage of the line, connecting nodes M and N. PST is the accessible path from node S to T without any line outage. Topological resiliency metric under normal condition. That is, how much resilient your system is during normal condition. That is assessed here. Then after outage. what is the value of resiliency. You see here that reactance of the line plays an important role. Then how much is the loss of resilience? 100 is the ideal value and QT is your instantaneous value after the loss of resilience. So that is integrated between time of initiation and it is the time when the performance indicator is recovered to original level, TF. So this is the loss of resilience. That is how much is the loss in capability of the system to restore. It is another loss of resilience. If the performance profile follows the triangular curve of resilience, then we can calculate this one. This is basically half base into altitude. That is the triangular loss. Then performance metric. Resilience is expressed as this, which I have shown here. Here we have taken exponential improvement in the restoration process. So this is a metric. It has another general form that is also shown here. From the instant of initiation to the time instant when the system reaches the final steady state value. Then performance curve-based resiliency metric. This is the ratio of areas below the actual performance. Resilient metric as a function of time. These are all the metrics developed by the researchers within last 20 years. Resilience metric take into consideration hazard events. It's an annual resilient metric for hazard age. Then recovery dependent resilient metric. R is equal to 1 plus alpha U by N. Alpha is the weighting factor to distinguish the relative importance of I and U. I plus alpha U by N. N is the normalization factor that allows to have resilient metric to have no units. I and U can be expressed by these formulas. Restoration level based resilient metric. Resilient metric based on power supply availability. This availability can be used here. Resilient metric based on economical aspects. Delta Y is the difference in expected economic output of the system between the pre-disturbance state and final steady state after recovery. And delta Y percentage max is the system economic output level difference between the no disruption state and maximum expected output level. Impact cost-based resilient metric. Now, if you go through IEEE literatures, these are the 4 quantitative resilient metric they have taken which are practically operable. So you see from the graph, these values are given in the graph. This is phase 1, phase 2, phase 3. Phase 1 is during the disturbance process. Phase 2 is when the disturbance disrupts the functionality. The system is trying to adapt the system. And then phase 3, the recovery, restoration process. So these are the time zones. So on this graph, these operational and infrastructural, the resilience metrics are taken into account. These are practically applicable and easy to calculate. Now, we have taken these and we have simulated these in the South Indian 62 bus utility system. These figures are all in, these values are they here. They are in kilowatt, that is 98.1 megawatt, 22.05 megawatt, like that. The generation capacity, you see that during disturbance, the resilience for generation becomes 77%. And when the disturbance is continued, the degraded state is achieved and the resilience is 55%. And post-recovery state, again it is coming to 77.52%. And this net area is practically the average, that is starting from the initiating event. At 63 hours, it started. It started at 63 hours. And entire recovery process completed at 148 hours. So these are the different. This is the disturbance period, 63 to 81 hours. This is the degraded state, 81 to 107 hours. And recovery period is 107 to 148 hours. So entire period is 63 to 148 hours. So during this period, the average, the area, that is the average of the resilience for the generation capacity is 70%. And the load resilience is similarly plotted here. They are calculated like this. So you see that load resiliency is higher than generation resiliency, because in many cases our generations are the thermal and hydro, the conventional one. So once the disturbance is there and tripping is there, it takes much more longer time to bring them back into system or to get for captive power. Spinning reserve is also less. So resiliency for the generation system is lesser than resiliency for the load system. Load includes distribution system. So if we conclude, we see that we need to assess the critical lines. We need to calculate netability used vulnerability. Then the voltage profile, network power loss using DG. Application of DG becomes important. Then you can simulate using the betweenness for highest electrical betweenness of lines. You can check. Then tripping of lines, how do they affect? How do they island the system? How critical fragmentation takes place? How cascading failure takes place? That can be checked for a system. And the resilience of the electrical network can be assessed using different resiliency metrics. Network resiliency deteriorates with loss of functionality of network and degradation of the performance level. So this much of the talk I have delivered so far. In case you have a question or questions, you can ask now.
Thank you, sir. If any participants wants to ask any question, please ask any question. I think someone has raised his hand. You can ask question.
Yes. Any question?
Mohammad Tohsif Ahmed, I think you have raised your hand. Can you want to ask any question? I think
There may be a network problem.
there may
Communication.
be a network problem. Sir.
Anybody else?
I am asking anyone, if you have any question, please ask the question.
Yes,
Sir is waiting. Okay, tell. Please tell.
Your
Sir, please
mic
tell.
is muted. Please unmute your mic.
what
Yes.
is the difference, sir? Is it, am I audible, sir?
Yes, you are audible.
So what is the difference between data analytics and the silent matrix?
Data analytics and this matrix are not exactly within the topic of discussion related to grid security. Whatever I know, that is on that data collection, we go for the statistical analysis to see what are the events, what are the impacts of the events. That we can check from this, and we take the help of statistical person to get a complete view for the collection of data and the results, from where we can conclude or we can take into care how the electrical system is affected. This may be in any sector, but we are interested in electrical grid. So grid affected data are taken. So that whatever we know about this thing. But
Okay,
as
sir.
far as I know, it is not exactly within the topic of grid security.
Okay.
Next.
One more question, sir.
Yes, yes.
In distribution generation, DG systems,
Yes.
radial distribution system, if we go for, so what are the real data we have to just, and what are the constraints we have to consider in real time in the silent matrix?
In
How we
the
have to,
in
yeah.
DG,
Yeah.
mostly we use DG in simulation and in practical in
Yeah.
the medium voltage bus. That is
Okay.
11 kV bus. So that
Okay.
it can directly give supply to the distribution system. So there we need to study what is the capacity of the DG and how much it can take care of the load during the period of contingency. So that is very important. So while you go for that, the main constraints is the data related to distribution system. In many cases in our electricity boards, the regional electricity authorities, we are not able to get complete data. If we get the data in detail, very complete data, then it is possible to go for such type of analysis. And as far as we know, you may be knowing better than me, the young engineers who are dealing with AI. Using the AI
Yes.
software, you may be able to predict how the DG is most effective during the period of contingency once you get all this data. So this much.
Yes, sir. One more, sir. When we are integrating the renewable sources in DG systems, so for at that time we required real data, and constraints are varying, sir.
Constraints are very high.
Yeah.
Usually we take the electrical constraints, but many times electrical constraints are not sufficient.
Okay.
But if we can take maximum number of constraints, then the simulation is more accurate.
Okay, sir. Thank you, sir. Thanks, very good, sir. We have got informative with your lecture, sir. And basically,
you.
I'm working research on some integrating renewable sources in DG systems.
Okay, fine.
Okay.
But
For
data
that,
may be difficult. It is very difficult to get the data in Indian system.
yes.
Actual data.
Yes, actual data. So randomly we are taking and just providing the AI application on value of
Right.
power compensating using
Okay.
sir fact device.
Next person.
Any other participants? You can ask the question. Ask any question. So, sir, thank you, sir, for your valuable and enlightening lecture. Professor Abhijit Chakraborty, sir, is ex-professor and ex-HOD of Department of Electrical Engineering of IIST Shibpur. Sir is the former Vice Chancellor of Jadavpur University, Kolkata, and former Vice Chairman of West Bengal State Council for Higher Education. Sir has published numerous papers and books on electrical power system, electrical circuits, and electro and power electronics. His research work includes power system analysis, power system stability and control, smart grids and renewable energy, power electronics, and electric drives. Sir, thank you, sir, for your valuable lecture. Your insights were truly invaluable. I am grateful to you, and from the participants also, I am giving you thanks for the knowledge you shared with us. Thank you,
Thank
sir.
you. Thank you. Thank you very much. And
Thank
best
you, sir.
wishes.
Thank you, sir.
Thank you. Thank
Sir,
you.
please share some of your latest paper on sir smart grid related in power system, sir.
Okay. Thank you.
Thank you.
Thank you.
Our next speaker is Professor Priyanath Das, Professor of Electrical Engineering Department of NIT Agartala. Sir will join shortly. I think sir has joined. And Professor Priyanath Das is presently working in NIT Agartala. He has completed his BE from Tripura Engineering College, presently NIT Agartala, ME from Bengal Engineering College, presently IIEST Shibpur, and PhD from Jadavpur University. His area of interest is power system and renewable energy. Professor Dash has joined NIT Agartala in the year 1996. Till to date, under his guidance, 10 PhD scholars are awarded, 2 PhD scholars submitted thesis, and 4 PhD scholars are ongoing through their research work. He has published paper on numerous SCI and Scopus journals. He has attended multiple number of national and international conferences. He is the member of different professional bodies like IESTE, IEI, FAWCET, IEEE, etc. And now he is serving as serving the charge of Honorary Secretary of Institute of Engineers, Tripura State Center. He has published different books, 3 patents. He has executed different sponsored projects. I would like to request Priyanath sir to deliver his valuable lecture. Over to Priyanath sir.
Good evening to all. I think I am audible. Am I audible?
Yes, sir. You are audible. Sir, but your picture is not clear. Okay. Your presentation, I think, it is now clear, sir.
Okay.
Okay, sir.
So now the slide is showing now.
Sir.
Hello.
Slide is showing.
Okay.
Yes, sir.
Okay. Thank you, Madam Kaveri, Madam, for giving me the scope for giving a lecture in ATAL FDP. So I will start right now. My presentation on sustainability in power system. So I will share some of my experience and some basic idea about the sustainability and power system, and also the power scenario of India, some related to the country. So this is the topic, and this is the content which I will highlight in this session. Now, actually, what is introduction? Actually, you know, all of you know what is actually the power system, and why actually we will choose in this topic the sustainability, and what are the challenges for sustainability in power related to power system that I will highlight in the presentation. So actually the sustainability in related to power system, we can highlight the 2 points we want to highlight, because sometimes when I give a lecture in the different places, so I face some questions related to the sustainable energy and renewable energy, and actually what is the meaning of sustainable technology. So at a glance, this is actually sustainable energy versus sustainable renewable energy. So if you see the definition of sustainable energy, so that the energy that meets the current needs without harming future generation, focusing on environmental, social, and economic impacts. That is the actually definition of the sustainable energy. And for that, whatever the technology we will use, that is the sustainable technology, you can say. And the same way, the renewable energy from that we know that the energy from resources that are naturally replenished over a short time. And what are the key points of the sustainable energy? That is the emphasis long-term environmental health, social benefits, and resources for the conservation of energy. And the renewable energy, what are the key points? Key focus, we can say the focus point, that ensures that the source of energy is continuously available and naturally regenerates. And if you see, if we distinguish the 2 things, the sustainable energy and renewable energy, we can say the solar and wind, that is the, we can say it is a renewable energy. Simultaneously, we can say it is the sustainable energy. So when we will call it the sustainable energy, when the responsibility developed, or sometimes suppose you know the biomass gas, biomass plants we have, but when we are using the tree for heating purpose, then we are deforesting the natural resources. Excessive resource we are using. So in that case, we cannot tell it's a renewable energy, it's a sustainable energy. But solar power, wind, hydropower, geothermal energy, or biomass, it's a renewable energy. So sometimes what happens, the sustainable energy ensures not just renewability, but also reduce harm to ecosystems and minimal long-term resource depletions. So same way, the renewable energy overlaps. The renewable energy sources like solar, wind are often sustainable, but difference, not all renewable sources are sustainable. So hydropower, we can call it a renewable energy, but when it damages the ecosystems, then we cannot call it a renewable energy. So what are the importance of the features sustainable energy and the renewable energy. So sustainable energy ensures energy available for the long term while maintaining ecosystem health and eco-friendly or economic stability. Reduces dependency on fossil fuel, cuts greenhouse gas emissions, and address energy shortages. So now here is the power scenario of India. The whatever the power we are generating throughout the country. So from where we are getting the power, and what are the power plants resources are available, that it shows in in this map. So we can call it a conventional power plant. So conventional power plant, renewable energy, or coal reserves, or petroleum or natural gas sectors. Whatever the resources we have, that we can we can see in the power scenario map. So conventional energy, traditional energy, what we are using right now, the coal, diesel, natural gas, nuclear, hydro, and pump storage. And renewable energy, small hydro, solar, wind, bio, and waste to energy. Sometimes what happens, from the waste product we can generate the power, that is called the waste to energy power. So coal reserves, we have the coal mines, lignite mines, captive coal mines, coal washeries, and coal blocks, coal fields. So same way the petroleum, oil and gas wells, LNG, refineries, LPG, ethanol, natural gas pipelines, petroleum products we have. So these are the at a glance the power scenario of India. Next I will show what are the installed capacity and other things, and contribution of the different parts, different countries, different states. So what are the contribution for the meeting the demand of the country. So generation category wise installed capacity, if you see the total, before starting the sustainable technology or sustainable power system, before that we have to know what are the power demand, what are the installed capacity of India, what are the demand of India, and how we are mitigating the power, from what are the sources, from where we are getting the power. So if we see the generation category wise installed capacity, the total capacity is around 4,07,796 megawatt installed capacity. And from that, this total power from what are the contributions? So this contribution, the mainly shared with the thermal power. So thermal, at least 58% power we are getting. Whatever power, total installed capacity power we are getting from the different plants, the 58% power we are getting from the thermal. That is around 2,36,086 megawatt. And the same way, the solar power, it is around only 14%, 15% as on today, 15%. And the total installed capacity is 60,813 megawatt. So biopower, that is 2.62%, that is very less, 10,700 megawatt power. And small hydro power plant in the country, that is hydro power, is 1.2%. It is around 4,899 megawatt power. And the same, the wind power is a 10.22%. That is around 11% wind power. That is around 41,666 megawatt power. And nuclear power is 1.66%. That is 6,780 megawatt power. And hydro, small hydro, is 46,850 megawatt power. So these are the actually power in power scenario of India in our country. And all the power plants are connected in national grid. From all the power plants connected in the national grid, and all the national grids are divided into 4 or 5 zones. And these zones, these national grid we are maintaining for power throughout the country. And so these, if we see whatever the power we are getting, so from the society, So which portion, state, central sectors, central government, state government, or private public sector? So from where we are getting the total amount of power? So if you see the scenario, the graph, so that is the 24.28%. That is the central government share. That is the central government is generating this amount of power. That is a 99,000 megawatt power almost, approx. And same way state government, state sector, there is a 25.74. That is around 1,04,959 megawatt power. And remaining the 49%, 98% power we are getting from the private public source, private sector. That is the public PPP model, or government undertaking model, or public sectors. So these are the actually power we are getting from the different sectors. Now, how this growth of installed capacity is increasing. So if you see the demand is how the demand is increasing. So if you see the hydropower capacity installed, so it starts from the independence in 1947. If you see the graphs, 2007 or 8 onwards, the hydropower generation is growth. The hydropower generation, that is the growth of hydropower, is tremendously increasing. And you see before that, 1947 to 2007, around 50-60 years, the demand is very less, growth is very less. But after that, the government has given some emphasis on the hydropower, and because we can go for the renewable energy, and that's why the hydropower installed capacity has been increased. Same way, the growth of installed capacity of thermal, even thermal also installed capacity is same. If you see, compared to hydro, the thermal is increasing linearly. That is also in the 2019, you see from 1947, it is huge growth is regarding the thermal generation or installed capacity. Same way nuclear, because the government has now decided to increase the nuclear power plant, and already in India there are 3, 4, 5 plants already started nuclear. So these also increasing currently. And then total installed capacity of renewable energy sources from 2002 onwards, 2019, if you see the graphs, huge demand is increasing, and installed capacity also increased, because we have to go for the alternative resources. So that's why renewable energy sources we have to utilize, and we have to install the renewable energy power plants. So these are actually the sustainable energy. There is urgent need for transition from conventional source to sustainable source, because the day will come, the coal or oil will be in crisis, and that's why we have to think the alternative way. That's why there is a urgent need for transition from conventional resource to the sustainable resources. And sustainable energy sectors has a huge employment potentiality. So when we will start the new technology, new generation, new resources, then also we need to implement that technology, or we need to implement some power plant, and then we need to skilled engineers, or skilled men, or training. So employment opportunity will be more. So with this huge potential, India can utilize sustainable energy in an efficient way to mitigate the deficit of the power. So till today in our country, there are some states, they are having some power crisis, shortage of crisis. That's why they are every day they are maintaining the 4 to 5 hours load shedding. But sometimes some states are there, the generation is more than the demand. So then they are supplying the power to the other states where the demand is required. So this way, unequal demand we can mitigate by using the national grid or zonal or national grid. So with the huge emphasis on suitable sustainable energy resources, India is inching towards green revolution. So India is again increasing the green revolution, because we have to go for the renewable energy, increase the renewable energy. So sustainable energy can truly aid in the India's mission of becoming global superpower. So if you see the solar or wind, India is the best position through the world, and is best position for potential in respect of renewable energy. So benefits of sustainable energy, if we go for the sustainable energy or sustainable technology, then what are the benefits we will get? So to avoid the high, we have the 5 zones throughout the country. All the zones are connected to national grid. So there we need to transport the power. For that we need to install the high transmission line or distribution substation or distribution. So to avoid the high transmission line, we can use the sustainable technology, that is the renewable energy, the solar microgrid or small hydrogrid or small solar microgrid. So we can install this. So to avoid recurring fuel cost. So you know that total traditional power plant or thermal power plant, we need the fuel or coal or the other resources. So to avoid this recurring fuel cost, the way of fuel cost is increasing in India, not in India, in the country, in the globe. So we cannot mitigate the fuel cost. If we can, fuel cost is increasing, our electricity tariff also will be increased. So to reduce this cost, we can go for the renewable energy, because the renewable energy cost is day by day, it is decreasing. So 10 years back or 20 years back, the total installed capacity, if we 1 megawatt solar power plant, the installed capacity 20 years back, it was around 6 crores. Now, if we go for the 1 megawatt power plant, it is around 2 crores. So now you see how the changes, cost is reducing. So this way we can go for the we can take the benefits for the sustainable energy. So now what are the needs for sustainability? So raising the energy demand, you see the global electricity demand is increasing by 2 to 3% annually. So every year demand is increasing, but the traditional power plant is not increasing, because if you want to go for the set of a traditional power plant, that initial investment is high, and it is not physically suitable in near future also. I will show some graphs. From that graphs you can understand why it is not physically suitable or viable. So environmental impact, now the 70% of global carbon dioxide emissions came from the fossil fuel used in power generations. So if you see the different power generations, and if you take the data, then we got the information that the 70% carbon dioxide emissions are from the fossil fuel, which we are using in the different power generation plants. So to reduce this, again we can go for the sustainable we can use for sustainable technology for renewable energy. So severe consequences like global warming, melting glaciers, and extreme weather events is the effect of the sustainable due to this technology. So fossil fuel dependency, over 80% of global energy consumption relies on non-renewable sources. So whatever the power we are generating, what are the power consumption? So 80% of the global energy consumption relies on non-renewable resources. That is a big question in near future. So these are depleting rapidly. So we have to think for that as researchers or the engineers. We have to think in near future. So what are the components of a sustainable power system? So the components mainly we can classify different things, different categories, but I will just highlight some of the points. Suppose the renewable energy resources. So renewable energy resources, the transition to solar, wind, hydro, and geothermal. That all of you know what are the renewable energy sources we have in India. So 84% potential, solar potential we have compared to the globally. So we have the potential we can easily use instead of the traditional power or fossil fuel. We can go for the alternative renewable energy sources, that is the solar, wind, hydro, and geothermal. So energy storage is another technology we are using right now. Suppose the battery, palm hydro, thermal storage are the vital for balancing supply and demand. So these are the actually energy storage we are using right now. And all these things are battery, palm storage, palm hydro or thermal storage are connected to the grid, integrated to the grid. When the demand is increasing, then we can integrate it. And then the smart grid. Now, the way the demand is increasing, we can optimize the distribution of power. We can use the optimize use of power. Otherwise, there will be losses. So, if you see the losses in India, around the 22%, 22 to 23% ATC losses are there. So, most of the losses are the distribution side. So, out of 23%, 4 to 5% is the generation, and 4% is the transmission, and rest of the distribution side. So distribution side is the maximum losses are there. To optimize these losses, we can integrate the smart grid system. So there we can reduce our losses, and we can get the information easily, and we can control the power, transfer the power, control the power from grid to bidirectional way. We can use this. So the demand side management, always we are encouraging consumers to shift the energy use to off-peak time to reduce strain on the grid. So the demand side management, we sometimes what happen if demand is increasing, so priority, we can give the priority, so we can cut the power from the non-priority sectors. Suppose the demand is increasing, then we can go for the load shedding technique for meeting the problems. Otherwise, there will be fault problems in the supply system. So renewable energy in power system. So that already we have discussed. Now you see the globally, the 29% of global electricity came from the renewable energy, renewable sources in 2023. You see the thermal power is 58% in globally, and 29% right now in the year of in 2023, it is around 29% globally power. We can generate the power from the renewable sources. So we have to increase this renewable energy. If we can from 29 to 60, then it will be better for us. So if you see leading countries, Iceland, they already 100% renewable energy. They are in Iceland country. They are not using the fossil fuel. They are not using the traditional power. they are fully renewable energy. They are using only the renewable energy. They don't require any oil, any coal, anything. They are using only solar, wind, and other renewable energy sources. So these they can contribute 100%. So Denmark also, they have they have installed the technique, and already 60% wind. They are using the total power, 60% power from the wind generation. But in India, our resources are the solar. We have the solar potential compared to the wind power. So we can go for the solar power. And now, what are the challenges for integrating the renewable energy? When we are connecting the existing system, we have the existing system. If you want to go for integrating the renewable energy in the existing system, then we are facing some challenges. Suppose the intermittency, solar depends on the sunlight, wind depends on wind availability. So we have to depend on the sunlight, that is the solar insolation, and also the wind speed of the winds, so that we can go for the install, or we can generate the power from the renewable energy. But we have to depend on the solar or the wind speed. Now the grid stability. So grid stability is the way we are maintaining the national grid. So grid stability, renewable sources creates the fluctuating energy flows that destabilize the traditional grids. So sometimes when we integrate the renewable energy, then in the grid system there is sometimes what happen, THD, total harmonic distortion, we can observe, because most of the cases the renewable energy are the DC sources. So if the traditional grid is AC and we can integrate the DC, then there is some challenges and some effects, and some instability is there. So we have to think for that, and we have to mitigate this instability. And if the total harmonic increases, then it will create a problem in the national grid also. So before connecting or integrating the grid or the renewable energy into the grid, then we have to think. We have to think for that. So this way, the integrate the role of energy storage. Already I told you, I have discussed the different types of battery, pump storage, thermal, or in. Now we have to think for the new techniques, new storage things. We have the researchers or the faculties, they are doing their research work for the storage, to increase the storage capacity or go for the alternative storage system, and research is going on for, in this case, for the storage system. Now smart grid for sustainability. So smart grid, now most of the country, in our country, the government has given the more emphasis on to convert the smart grid, to install the smart grid, so that smart grid is a modernized grid with IoT sensors, real-time communications, and also automations. So if we install, if we set up the smart grid system throughout the country, our system will be totally automation with a IoT-based sensors or real-time communications. So we can get the information, we can give the information. That is a bi-directional information we can get, and also we can monitor, we can get the easily information. If some faults are there, some information that easily we can get, and we can control it, monitor it. That's the totally automation system. So this smart grid is most important right now to maintain the sustainable technology. So now, what are the functions? Enables integration of renewable energy, renewables, and enhance the reliability and also reduce the energy losses. So it's obviously, if we go for the new technology, install the new technology, then the reliability, stability, efficiency, everything will be increased, and also simultaneously the energy losses will be reduces, because the whatever the drives we are using right now, it is a power drive based, and the efficiency is high and losses are reduces. So so in the globally, if you see the meter, smart meter, advanced metering infrastructure. Now in our country we are installing the smart meter. So smart meter using means the ATC loss we can reduce it, and we can easily get the information of where is hacking is there, or some power leakages are there. So we can get the information by using the smart meter. So the smart meter project is going on throughout the country. Now the role of technology and innovations. So energy generation advancement. So now different techniques we have already researchers or the research institutions, they have made some product or technology we can install in the practical life, or in the practical areas where we can, in the distribution side or the transmission side, we can use it and we can get the benefits. So the perovskite solar cells. So these solar cells we have developed, and these the revolutionary solar technology offering higher efficiency at a lower cost. Now the solar efficiency is as on today 15%, 14 to 15%. But if you use this technology, perovskite solar cell technology, then we can increase the efficiency of the solar cell around 23%, 22%, and also we can reduce the cost of the solar cell. So that's why we are ready to use the latest technology So floating solar farms. So if solar panels installed on the water bodies to save the land space and reduce the evaporations. So sometimes what happens, some barren lands are there, or some water bodies are there where we are not using. So from there we can install the floating solar cell, and we can generate the power, and we can integrate the power to the grid. And also this by installing this solar power plant, we can reduce the evaporations. Okay, so vertical wind turbine. So already one company developed the vertical wind turbine designed for urban environments, and these turbines are more compact and quieter for the others. So this is very compact turbine we can use in the rural areas, so that we can use the latest technology for the areas. Now the grid management technology. So already I have discussed the smart meter and AI or machine learning based also technique we can use in the smart meter, blockchain, and also the energy storage industry. Okay. So these are the things we want to install in the technology in the area. Now role of technology and innovations. So if we see what are the technology we have just now, I have discussed the perovskite solar, floating solar, smart meter, AI based, and hydrogen fuel cell. These are the contribution. Now they are contributing this percentage. Suppose the perovskite solar cell is a 20% contribution technology in our country we are using. Same way floating solar, it is around 15% share the solar power plant. Same way smart meter is around 25%. Same if you use the our country use the AI based or machine learning based technology for sustainable, and the hydrogen fuel cell. These are the technology right now we are using in the power sectors. So these are the technology we can call it a sustainable technology. Sustainable technology means it can we can use it, and there is no harmful for the environment or the society, and also it will in long run it will help us for our society and eco-friendly environment. So these are the global energy consumption review. If you see the fossil fuel, 80%, already I have discussed the fossil fuel, the 80% the fossil fuel, and 29% is the renewable energy. So so these are the contribution globally energy consumption as on 2023. So fuel consumption. So if you see the global liquid fuel consumption, it is 104.46 million barrel per day. The fuel consumption in globally. So reserves, what are the reserves? 1.7 trillion barrels is a reserve. So if we are using same demand, same amount of consumption globally, so what will be the life cycle? Around 50 years. After 50 years, there will be no reserve for oil. So this is a crisis for us. So for that, we have to go for the alternative way. That's why we are thinking for the renewable energy resources, and for that we have to think. We have to think for the sustainable technology, so that we can reduce the losses and we can get the power consumption. We can reduce it. Consumption we can increase it. Simultaneously, we can reduce. We can also reduce the. We can increase the life cycle of the solid fuel. So these are the fuel consumption. If you see the global fuel consumption, petroleum, natural gas, coal, and renewable, and also the life cycle. Petroleum, gas, and coal. You see, renewable energy is zero. But if we can increase it, because natural gas is the highest we are now, right now we are using, and the 7,000 billion barrel per tons. So we have to think. That's why you have to. Now the crude oil, the crude oil consumption is around 99.4 million barrels per day as in 2023, and also the oil consumption is around 4.8 million barrels. Now what are the reserves? Life cycle is around 50 years. We can use it. After that, we will not. We are not in a position to use the oil, crude oil like this. So if you see the graphs, the way demand is increasing and consumption, resource is decreasing. Resource we are utilizing. After 2050 and 2020, you see the crude oil.
Hello, sir. Hello. We are unable to.
Hello.
Hello. We are unable to
Hello?
hear, ma'am.
Okay. Wait. Some technical issues are there, I think. Please wait.
Yeah. Okay. Ma'am.
Hello, participants. I think some problem is going on the expert's laptop. He will be delivering soon. Please wait.
Okay.
Sorry
ma'am.
for the technical disturbances.
Okay, ma'am. Okay.
Hello.
Yes,
Hello.
sir. Yes, sir. Yes,
Acha,
sir.
okay. Just wait. This is the sustainable technology. Now we
You are
sustainable
audible, sir.
sustainable.
No problem. You please continue.
Ah, okay. So, okay. So these graphs actually we can these graph shows how what will be the near future in future. So you see, in 2050 we will be in crisis for crude oil. Then our whatever our power plant we have in our country, every power plant will be in crisis. So our generation of power will be decreases. That's why we need to think right now for the renewable energy. That's why the sustainable technology is required. Now already that I have coal, same the coal thing, coal consumption of India is the coal second largest coal consumer with a 778 million tons consumed in 2022. So reserves, what are the reserves? Globally reserves 1.1 trillion tons. India holds 344 billion tons. So life cycle, that is if the what were the coal power plants we have, that up to 120 or 130 years we can survive by using the coal, or we can generate the power by using coal up to 100 years or 150 years more, not more than. So after that we will be in crisis. That's why we need to think for alternative resources. So these are the graphs. Again, you can see life cycle. And now that already I have discussed the solar, the highest potential in our country, where the different renewable energy resources are available. If you see the graphs in Indian graphs, then solar insolation or wind speed or thermal or hydro power plant. So the highest potential in Rajasthan and Gujarat. And I got the information that in Rajasthan, Gujarat, there are 800 into 2, 1600 megawatt power plant, and the solar power plant already installed in Gujarat. And also the key wind power is a wind power potential available in the Tamil Nadu, Gujarat, and Maharashtra. And thermal, that is already in Jharkhand and Chhattisgarh. This area is actually the coal-based power plant. That is the thermal power plant. And hydro potential is Himalayas regions, Uttarakhand, Himachal Pradesh, even Assam. Also, the hydro power plant is potential is having. So now, if we see the state-wise, suppose the Andhra Pradesh, if just states which are contributing more, just I am giving some example. There was the Andhra Pradesh. So Andhra Pradesh, you see the thermal, then renewable, and then hydro, and then the nuclear. If you see the black bar, is a thermal power plant, is around 58%, and renewable energy is around 38%, and the solar is around 2 to 3%. So the way thermal is increasing, thermal power generation is there, and then definitely the carbon dioxide, carbon emission will be more, and the pollution will be more. And same way the Assam, thermal, renewable energy very less, and then hydropower is better. So Gujarat, thermal, and then the renewable energy is compared to Andhra and Assam, Gujarat is better. Now the Karnataka, if you see the Karnataka state, the renewable energy is higher than the thermal power and the hydropower and the nuclear power. So this is actually things we want to need. We need the renewable energy and hydropower energy will be, if we can increase, then we can definitely reduce the thermal power. That means we can increases the we can reduce the carbon emission and pollution. We can reduce the pollution. So the Kerala is also same. Maharashtra thermal is highest is around 68%. Where is the renewable energy around 25%. Hydro is very less. But in Tamil Nadu and the Rajasthan, you see the Rajasthan, the highest, Rajasthan is the highest, around 68% is the renewable energy, and thermal is around for 38%. Nuclear hydropower is around 5 to 6%. So Rajasthan is better compared to all the states. If you see the contribution, that is a mixing of power for different sources, the Rajasthan is the best. So we have to follow that means we have to follow this Rajasthan. Then our thermal power will reduces, renewable will be increases, hydro will be increases, and then pollution will be reduces. So these are the now what are the economics benefits of sustainable power system. So definitely, if you go for the renewable energy, new technology, we have to go for new technology. Then we need to definitely the job opportunity will be more. So I think we got the statistics that within 13 million jobs worldwide in 2020 is generated, and solar and wind industry are the largest contribution to the employment. So if we install the solar or wind, definitely the industry will come. So manufacturing industry will come, and then the employability and the employability will come. And also the cost effective. I have given one example. The 1 megawatt power already. The 1 megawatt power, if we right now install the traditional power, is around 6 crore. If we install the solar, it will be around 2 crores. So that means that if we start now the solar, then our cost investment will be more. But 20 years back, we had the idea that investment of the solar cost is higher. Now it is directly opposite. I will show one slide. There you can understand. You will understand the difference. So now if you see these graphs, the renewable energy, the earlier the investment cost is more. Now 2010 investment cost is more. Now in 2025 investment cost is reducing. Now it is very less. Now the traditional power fossil fuel investment cost is less, but the in 2010, now 2025 investment cost is increasing because fossil crisis is there. Fossil fuel cost is increasing. Cost is increasing. So if you see these two graphs, you can understand the actually why you have to go for the alternative resources or the renewable resources and sustainable technology. That is the main things. So now the environmental impact reduces greenhouse gas emissions. Renewable energy, renewables like solar and wind power produces 90% fewer from carbon dioxide emissions compared to coal and gases. So the conservation of resources, positive biodiversity effects, that is the most important thing for the environmental effect. So now the environmental, you see the graphs, the coal, natural gas, and well, how the carbon dioxide emissions by energy, different source of energy. The coal, if you are using coal, the highest producer the carbon dioxide, and compared to the natural gas, it is very less. So now the social benefits, if we use the sustainable technology, that definitely it will affect the society. Cost will demand side will be increased, less losses will be reduces, efficiency will be increases, tariff cost will be lesses. So all these things, and also the reliable and clean energy improves the health outcomes by reducing indoor and air pollutions. So all these things are the benefits for society also. So these are the graphs. If you see the Africa, India, Southeast Asia, and Latin Africa, then you can understand the improvement of rural literacy, how we are giving the importance on the rural electrifications by using the solar renewable energy. So now the government has some responsibility for improving the power quality or generation, or changing the technology, or installing the new technology in the country. Government has some policy and regulations. So now the role of governments, what are the different the central government, state government have different rules and policies are there. So we can explore all those policies and regulations so that we can improve the power sector in the country. So these are the policy. If you see, the India is only the 26 or 20% subsidy we are giving, but other countries, China is giving the 60%, more than 60% subsidy for renewable energy, sustainable energy. So now also we have to think for increasing the renewable energy or sustainable technology. Now if you see the case studies, so Denmark, if you see the Denmark 60%, already I told you that 60% power we are getting comes from the wind energy. Goals of to become completely fossil fuel free by 2050. So Denmark government has taken that decision that we have to go 100% go for the wind energy or renewable energy. Already they achieved the 60% by 2023, and now by 2050 they will declare achieve the 100% renewable energy. India is also we have also target. Suppose we have the by 2022 we have the target the 175 gigawatts renewable energy, and also it is increases by 2030 it is around 500 gigawatt. So India is also increasing the renewable energy. So now what are the challenges in achieving the sustainable technology? So there are lots of challenges we have to face for installing or other things. Suppose the financial constraints. So financial constraints, the high initial costs are for renewable energy infrastructure, limited access to funding in developing countries. So technology limitations we have. Suppose the grid modification is costly and complex. Suppose whatever we have the existing national grid, if we want to change the smart grid but convert the smart grid, so then grid modernization is required. For that, we need to some financial support or financial involvement is required, and also the technology is required. But sometimes what happens, we know we have the technology, we have the fund also, but sometimes we the practice engineers or the field engineers are facing the different political or social barriers, oppositions from fuel industries and stakeholders, and so these are the things challenges for achieving the sustainable technology. Now we have to think for future trends in power systems. So whatever the problems we are now right now facing, we have to overcome things and we have to go ahead. So for that, hydrogen economy, or advanced nuclear energy, carbon capture storage, these are the most important things right now. In future, we have to think our we have to research for these three areas, and then we can reduce the cost, everything, latest technology, new technology, simple technology we can use. So these are the challenges we have to think in future also. So these are the trends. If you see the trends, green hydrogen and the small modular reactors or nuclear reactors. If you see the green hydrogen is the best and better for us in near future. So for that, the researchers need to go for research in the green hydrogen areas, so that they can give some latest technology or develop the new or invent some new technology so that we can implement in near future. So these are the things right now whatever we have discussed. So the conclusion part, I can say the transition to renewable is essential. The shift to renewable energy sources like solar, wind, hydro is critical for reducing greenhouse gases emissions and combating climate changes. So the technology in innovations are driving progress. So advanced technologies such as smart grid, AI, energy storage, or hydrogen fuel cells are enabling more efficient and sustainable power systems. And also simultaneously the government has to think for different policies or regulations so that it can play a better role for supporting the industry people or the private sector or government sector, so that they can come forward and install the take part for generating the power. So economic and social benefits are the significant. So economic, definitely we have to compete the globally, because of whatever the now the global every technology is globally available, and whenever we go for any industry setup or power plant setup, then the tender will go for the globally, and global bidders and come, and the competitions is there. So the cost we can compare, or the technology we can compare, and we can go for the sustainable technology we can choose. And now the challenges need for collaborative solutions. So financial, technical, and political leaders must be addressed through the coordinated efforts between the government, industries, and the communities. So, a vision for the futures, achieving sustainability in power system ensures a cleaner, greener, and more equitable energy future for generation to come. So, with this, I have concluded here now. So, if you have some questions or doubts, you can ask me. So I don't know whether. Hello. 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 Whether I'm audible.
Uh, Hello, any participants? You can ask any question.
Yeah, Dr. Das, this is Ardhendu from Mumbai. Your lecture was quite interesting
Okay.
and
Thank you.
enlightening too.
Thank
I
you.
too in
Thank you.
industry and
Okay.
working for solar power
Okay. Good. Very
in
good.
our
Now
private
solar is the
sector.
future. Solar in our
Yeah,
future. Not
that's
future.
correct. But
Yes.
government of Maharashtra has adopted few policies. Like they
Okay.
give 50% deficit in first year, followed by almost all by 3 to 4 years you are
Okay.
totally overcoming the total capital cost.
Okay. Well, very good.
That is
It's a
going
very
on.
good policy of the government.
Yeah,
This way
government
we
is
have
doing
to
very
change.
good policy. Yeah, we are getting
This way we have
depreciation.
to change. Otherwise, in future we have to suffer for power.
Yeah, definitely.
Otherwise, you have seen in the 2012, you have faced the blackout in Maharashtra and southern states, western countries, western
Nice.
states.
Yeah, nice to see that you have done a lot of research on this. But one slide was I
I
was
am not doing anything. My scholars are doing everything. They
yeah,
are
definitely.
giving me
But
the
it's your
information.
team, and credit goes to the leader. The
Thank
question
you.
is that
Yeah.
one slide I have seen that you have shown. Currently, we are at 2.5 gigawatt of renewable energy. And our ambitious target is 500 gigawatt by 2030.
2030.
It figure seems to be real unrealistic. I think so.
No, that is actually what happened. Actually, our target is by 2020, it is around 175 gigawatt.
Yeah.
But we
Okay.
cannot achieve by 2021 175 gigawatt.
Yeah.
So there is some which because I am not also getting the information from ministry sites. Ministry is not updating all the things. So
Because
what we are doing actually, we are
yeah.
getting the information. We have to take the information from the ministries because that is authentic data ministry is having. So
Yeah.
we are collecting data from the ministry side or the research institutes. We are getting the data and we
Yeah.
are putting. So
Yeah.
if it is a mismatch, it may be better.
No,
Definitely, I will
that's
think.
correct.
I will take care. I will take
It
care.
is nice. We must have a beautiful
Okay.
target to see.
Yeah.
But question is that problem we are facing in Maharashtra in all the industries that central government is trying to implement a lot of policies, but state government is having its own reservation because as soon as the renewable energy share goes up, the fossil fuel or the electricity distribution company, those are running a big network and business.
Yeah, that is the
It
challenges
is
now. That is the challenge. So we have to mitigate the challenge. We have to. That's why now. That's why I have last conclusion part. I have said we have to challenges the financial, technical, and political barriers must be addressed through the coordinated efforts between the governments, industry, and the communities. So government, central government, state government. That's why I have given the data now on the sectors. 25% sectors from the state, 25% central, 50% from the public, from the private sectors. So
Yes,
that
yes.
in that case, the government should come forward.
Yeah, yeah.
The
That is
government
the
is the
big
third
challenge.
party. That should. That is the big. That's why that third party is required in that case.
Okay. Thank you.
Otherwise,
Thank you very
government
much
have to
for your
intervene.
nice presentation.
Thank you. Thank you. Thank you.
I'm over. Anyone can put any question, please.
Any other participants? You can ask the question. Ask any question.
Actually, I am not. I am supposed to give the lecture on 22nd. I am not prepared today's lecture, so but
So,
still I tried.
But it was quite interesting. I was just listening to you as well as watching your slide. It was quite interesting and nice to say that you have done a lot of work on this. Because it's a big challenge to India as well as global.
Even if you see the 87% potential, solar potential is India only.
Yeah, definitely.
But we are not in a position to grab this potential. Only the 20%, 15% potential we are using. So if you can increase the 30%, then that is a huge achievement for India. They have the policy. So now I don't know the state government what is their thinking.
No, but quite a few states are coming up and they're compromising with the central policies as well as.
Even there is even now, sir, in our states, we have the installed capacity is more than 1080 megawatt. Okay, but our demand is only 350. Now we are selling the power to the Bangladesh. We are sending to the power to the Kashmir. We are selling to the power to the Maharashtra also, even Nepal. So that's a good thing. Now we have the surplus power, but demand is Maharashtra and southern country or the western country is more. So they need the power. Suppose I got the information the Bihar 4 hours load shedding is every day.
Exactly.
Okay. So if they can get the power from Tripura, they can easily get. But you see the solar potential, Gujarat, Tamil Nadu, even Kashmir also solar potential, solar installation is very good. I've seen it is around 4.5 and 5 also. But 4 solar installation throughout the country is very good. So we have to think the solar installation, where is the most best solar installation we have. So we can grab the solar installation. The state can easily grab the opportunity.
But the question is that state is looking for revenue. So that is the reason they are having little reluctant to this solar power.
Now you see, sir, you see, 10 years back, if we want to install a 1 megawatt power, the cost is around 6 crores. Now it reduced to 2 crores.
2 crores, approximately.
So the technology is changing. Now technology reduces the cost. Now easily we can use it. Now that we have to think. Now that's the thing. So,
sir, we are very much thankful to you. Anyone, please? I think no one has any question. So we are very much thankful to you for your valuable lecture. We have come to know about the sustainable technology from your lecture. So really a very informative lecture it was. We thank you once again, sir. So for your valuable time you have spared for us. Thank you. Thank you once again.
So
and all the participants are requested all the participants are requested to fill up the 2 Google forms we have sent in the link as well as in the chat box also. You please fill up this. This will be considered as your attendance.
Thank you, sir. Thank you for nice
I
lecture.
request to all of you, all the participants, if you need any kinds of query or information, please don't hesitate. You can call to me or you can send me a mail to me. So anything regarding research or information, you can contact to me. Okay. And I'm sorry for technical interruptions. My laptop is not properly functioning. Yeah.
Okay, no problem, sir. Okay, thank you, sir.
Thank you.
So we are concluding now. We are leaving now. And tomorrow the class will be started from 6 p.m. So all of you are requested to join the class in time.
Ma'am, with the same link or you are sending one more link for tomorrow? Huh?
Same link will be active.
Okay, thank you.
Okay.